Today we are talking about functions, right? And we're talking about how to identify a relationship that is actually classified as a function versus something that's just called a relation. All right, guys, every single graph and table and set of points and maps, all of these things are relations. Relations are just really super general, all right? A relation is just any set of ordered pairs, any set of related x and y. Okay, so let me give you a quick example. We could say the point 0, 0. Actually, you know what? Let's do this with parentheses here. So we're going to do it as a whole set. So the point 0, 0, and the point 2, 3, and the point 2, negative 7. All right, this is a random group of points. Okay, this right here is a relation. This will make more sense as we go along here. Okay, a function is actually special. A function is a special kind of relation. All right, we have to be specific. By the way, just a reminder, you can pause the video if you have not finished writing down that definition over there on the left. All right, a function, okay, it is a relation, right? It's a special relation. It's a relation in which each element of the domain, which we will also learn the meaning of that word, corresponds with exactly one element in the range. Okay, so again, domain and range we're going to talk about in the next few days. Here's the main point, y'all. Here's what I really, really, really need you to remember. Okay, every x has only one y value. Every x value has only one y value. All right, that is the main idea for this. Let's go on and let's look at a few different examples. So we're going to look at these 4 different graphs. I am going to do the first two, A and B, and then I'm going to have you do C and D over to the side. Okay? The way that we determine whether a graph is a function, right, if we can define it as a function, is if it passed something called the vertical line test. You may have heard this before. We look and we see, does a vertical line intersect the graph in more than one place? Okay? So, see how I can draw a bunch of vertical lines on this first one? Do any of these lines that I drew touch my graph more than once? No. All right, so this right here, we're going to say it is a function. We're going to say it passes the vertical line test. Passes the vertical line test. All right, all those lines touch only once. But if we go over here to the right, on this graph, if I draw even a single line, it's touching twice. Now, it's true that I could maybe draw a line over here where it only touches once, but if it ever touches my graph in more than one place, these vertical lines, we say this is not a function. Okay? It's not a function, right? It did not pass the vertical line test. Okay? I'm going to have y'all go ahead and do problems C and D over there to the right. Problem 2. This is easily the most confusing of all the different examples because you need to really think hard about lots of different possible cases. Okay? So remember, every x, so all these things on the left, need to have only one y value. Okay? All right, so we're going to look at first option A. Okay, city. Does each city have only one area code? We're going to say no. not a function. For example, lots of you guys live in McKinney, but some of you have 469 area codes and some of you have 214 area codes, right? So you can live in one city and you can have multiple area codes. That makes it not a function. Problem 2, the number of students in a class and the class average. Okay, so maybe a random example. If I have 10 students in the class, does that mean I'm going to get a class average of 90%? No, like there's really not even a relationship here. So we're going to say not a function. For this one, I'm going to say just no relationship. It's not even a relation, right? Not a function. It's also no relation. Number of students in a class does not affect the class average typically. Okay, C, the total number of Girl Scout cookies sold and the number of girls in a troop. Well, think about it this way. Does it mean that if, okay, you tell me that there are 21 girls in your troop, that for some reason I should know exactly the number of cookies sold? Or sorry, I should have said that backwards. If you tell me, hey, my troop sold 98 boxes of cookies, should I then know the amount of girls you have in your troop? No, that's not something that we can really control. So we're going to say no, not a function. Right? One does not belong with one other thing here. It's too vague. Example D, your height and your grade in a class. Y'all, we know that your height does not affect your grade in the class. We're going to say not a function, no relation. And then this last one. The number of students attending a tailgate and the total ticket sales. So if we're assuming that every single kid pays, which we are, right? Nobody's sneaking in. If we say that the number of students at tailgate, let's say, 277 students attend, should we then know the total ticket sales? Right? They're all students. They should all be paying the same price. This is a function, so we're going to say yes. Okay, the number of students attending, right, buying tickets, tells us the ticket sales. Okay. Now I'm not going to ask you to do any of these examples. Over on the right, just go ahead and pick the one that you think best represents a function. So instead of doing like yes, no, kind of like we just did, just out of your 4 scenarios over on the right, choose the one that you think would represent a function. Okay, problem 3. We've got 3 different tables here. So we're trying to find out if each one of these tables represents a function. So remember what I had you write up top? Every x has only one y. This will help you understand. All right, we're going to go ahead and we're going to look at the left. All right, I've got 1, 2, 4, 3, 4. Uh-oh. All right, take a look. I've got 4 is in my table twice. So this is telling me that when x is 4, I get a 6. But then also when x is 4, I get a 9. This right here means this is not a function. This should not happen. You should never have multiple x's in a table. Okay? So then we can go ahead and we can look at example B. We've got 4, 2, 5, 7, 3, 8, 1. So none of these repeated. Now on the right, we do see that I have a 6 and another 6. Guess what? We don't care. We don't care about y. We don't even have to look at y, honestly, right? We really don't even have to look at y when we're deciding whether or not we have a function. We only look over here on the x's. And since none of these x's repeated, right, we do have a function. You're going to go ahead and do problem C over there on the right. Okay, example 4. We've got a bunch of points here. My brain doesn't do this very well, so whenever I get a list of points like this, I always make a quick table, right? So all my x's, let's see, I've got -1, 0, 2, 10, right? Because the x is always the first one. So -1, 0, 2, and 10. And then the y's just go right next to it, right? So -1 goes with -4, 0 goes with 0, 2 goes with 8, and 10 goes with 40. And now I can easily see. Have I repeated any x values? No. All right, so yes, this is a function. So we'll say no repeated x's. Okay, you go ahead and do B over on the right. Problem number 5. This is something called a mapping. This is a little bit strange. This is something that you've never seen before, perhaps. In the mapping, I would strongly encourage you guys to make a table, but it's going to take a little bit more work here. So what this is saying that 6, when x, this is the left and this is the y, sorry, this is the x and this is the y. So when x is 6, y should be -4. You just follow the arrows. When x is 7, y should be -3. When x is 8, y should be -3. And when x is 9, y should be -6. So again, we don't really care about the y's. We're just looking here at the x's. Since I don't have any x's being repeated, I'm going to say yes, it is a function. Now I'm going to do option B, and I'm going to give you guys a new problem over on the right. So you're not going to be able to do it on the paper. Just go ahead and do it in Edpuzzle, okay? All right, on the right, make another table. Here we go. We see that when x is 0, I'm getting 0. When x is 0, I'm also getting 6. When x is 1, y is 2. When x is 3, y is 0. All right, do we notice that we have 0 repeating in our x's? Okay, that means this is no, not a function, right? Our x's repeated. All right, finally, example 6. I'm going to do A. You guys get to do B. Let's go ahead and let's take a look. Now we could do this a couple of different ways. We could make a table for all of these points. But do you remember back on the first section where we were able to just draw vertical lines to just test and see if it hit anywhere twice? We can do it even when we just have these graphs that contain only points. So I'm going to look at example A. If I put lines where my points are, only hitting once, only until I get here. See how here I have a graph, sorry, I have a vertical line that's hitting my points more than once? Okay, that means that this is not a function, right? When x is -2, I'm getting a 3 value for y, and I'm getting a -4 value for y. We can't do that, right? So not a function. All right, you go ahead and do example B, and then don't forget to go back to Canvas and get your code for quizzes, and make sure you get that done before you leave class today, or if not, by 11:45 p.m. tonight.